I have to say. Well, thanks everyone for coming. I have the pleasure of introducing Peter, and I have some notes on you. So Peter O'Gorman is a business intelligence specialist and director of BICG, the Business Intelligence Consulting Group, currently working on solutions in the health and energy sectors. Peter is passionate about helping people to understand the value of their data and to better help what's going on, to help them make better decisions, and to help them shape the future. Peter also writes his own blog, and it's a very interesting blog, and as you can see how the introduction to this talk already gave away that it's going to be an interesting and fascinating journey tonight. I think it's a good idea to have a look. It's called Pop BI or Popular BI. With no further ado, I'd like to introduce Peter. Please give him a warm welcome.
Thank you, Matthias, and yeah, thanks for coming along. So tonight we're going to go on a journey to predict the next rogue wave. My name is Peter, and I am going to start you on a short introduction video. Oops.
There is something out at sea, terrorizing the world shipping. Out of the darkness came this great wall of water. I've never seen a wave as big as this in my whole life. It can strike out of the blue with devastating consequences.
You hit solid water and it's like running into a brick wall. The entire bridge was wrecked.
Monstrous. You feel as if the end of the world has come. This is the story of a wave that is sinking ships around the world. A killer that defies all scientific understanding and that no ship is designed to withstand.
Okay, so that was a video from a TV series called The Freak Wave, and it was a BBC special. So my name is Peter O'Gorman. I'm a director of BICG and BI Consulting Group, and a business partner down there is called Carl. He's come for support. And we're specialists in business intelligence, predominantly in the Microsoft space, but using some other tools like Tableau, and we do SAP to business objects migrations. In tonight's presentation, we'll take you on the journey of the rogue wave, and we'll explain what that is, and why it was such a threat to the ships of the cargo and the passenger ships in the oceans of the world, and how the scientists and the mathematicians went about solving the problem of the rogue wave. We contrast this problem to the problem that regular businesses face every day with regular interactions, and we look at how having access to data in the right way can help to solve those problems and help businesses predict the next wave, whether it be an opportunity or something devastating. We'll also take a quick tour of our data departments tonight, and we'll do a quick recap on methodologies for building data warehouses and the data discovery movement. Hopefully at the end of the night, you'll walk away with something new about the topic of data exploration.
In order to predict the biggest wave a ship will meet, scientists use a set of mathematical equations called the linear. This says that in any sea condition, there is a limit to how big the largest wave will be, and that mariners' tales of monster waves that come out of nowhere have got to be wrong.
Mariners are like fishermen, aren't they? I mean, they come back from the sea and they tell all kinds of interesting stories, and people look at them suspiciously.
It's sort of like,
you know, the fish that got away. And he says, oh, that was 10 meters long. You know. Well, waves are sort of the same.
Jim Gunson of the Met Office uses the linear model to explain why freak waves shouldn't exist.
Using the linear model for a given sea state, this L-shaped graph gives the probability of a certain wave height. And it's like in a population of children in a class. There's an average height of children, and most children are around that height. Some are quite a bit taller or shorter. There's the chance that a child is 3 or 4 times the height of the average child is very, very small.
So, according to the linear model, even in a fierce storm where average wave height may be 12 meters, the chance of meeting a 30-meter wall of water is practically zero.
So what we had here was demonstrated evidence of ships sinking and sustaining massive damage, and no mathematical model to support these claims. No solid backing from the worldwide community to work on a problem. So at the end of the presentation tonight, we will continue the third and final part of that video to figure out how mathematicians did actually solve the problem. But what was more interesting is the creative process, so the people component used to actually solve that problem, and how they used data collection and thinking around solving rogue waves. So we'll now contrast the idea of the rogue wave to our businesses and the problems and the threats that we face every day. It is my goal this evening to highlight the most important ingredient in the whole business intelligence process, and that is the people. And the technicians quite often get more wrapped up in the technology rather than focusing on the business. And why wouldn't they? We have in-memory databases, we've got cloud solutions, we have predictive analytics. There's a lot of cool stuff out there, and technicians can get quite wrapped up in that. But the business wants to be more responsive and agile, and it's important for us to support that creative process. So in the next few slides, we're going to cover innovation. So we're going to cover that people side of BI that we don't see too much, and we're going to understand innovation, and we're going to understand the creative approach to solving problems and how data exploration fits into that. So innovation, in any business there are different types of innovation. Steve Jobs quoted that innovation distinguishes between a leader and a follower. A business can innovate in several ways, as you can see. Product innovation, which is about new and better products. Service innovation, so new and better service offerings. And right down to brand communication or even organisational innovation, so improving the way you deal with your employees. So the creative approach to problem solving requires business to first identify the types of problems and really understand the problems they're facing, whether it be a rogue wave or a changes in the supply market. And then they generate solutions to these challenges, deciding which ideas to progress and prioritise, prototyping and piloting ideas to actually figure out the best way forth, and then how to implement these ideas, and more importantly, how to evaluate the success of these ideas. So this is where in each of these steps that data exploration has a role. So that makes all perfect common sense, but for our data department, sometimes they're seen as business prevention. Some of the ideas or words that have come out of businesses in my time as a BI specialist, and probably some of the best ones there are that IT asks what we want and we ask what we can have, but the circle goes round and round and we don't end up getting the information that we need. And also the business want access to the data themselves. It's a two-way street, so IT doesn't really like the business either. So typical responses from IT are, the business are cowboys. And we don't support that technology, so you're on your own. You have the platform and you have to manage what's in it. And we're all about a quality solution, not a quick and dirty. So let's do a quick recap on what is happening in our data departments. And data warehouses are commonly built of one of two main schools of thinking. So we've got the Kimball methodology, so it's all about quick wins and quick wins on the board for the business, so money in the bank. Especially designed high-performing data models wrapped around tightly specified business requirements, and ideal for small to medium operations in the business, not organisation-wide. So the main criticisms for Kimball data models is they're not comprehensive or detailed enough to support data discovery, so the unpredictable questions from the business. And over time, the star schemas tend to not be relevant. Inman is the second, and both are very good. So Inman is more of a top-down and comprehensive approach to building data warehouses, subject-oriented or organisational-wide. The main criticism is just that it takes a long time and it's expensive to build one of these Inman data models. And then we have the idea of data exploration and what that means. So in the next couple of slides, I'll endeavour to explain how data exploration is positioned in building and servicing data requests. Here we have the Gartner Magic Quadrant, and I apologise if that's a bit small, but essentially, who knows what the Gartner Magic Quadrant is for BI? Just one person? 2? 4? All right, fantastic. So if I just go through the basics here, the Magic Quadrant is a rating of different vendor offerings in 4 different quadrants. So they competitively position the vendors against each other. Leaders in the top right execute well against their current vision and they understand the market well. And then down in the bottom quadrant are the niche players. So they focus successfully on a small segment and they don't really care about anything else. So I guess, we have some of the regulars there as far as IBM and SAS and Microsoft and Oracle sitting in the top right-hand side in the leadership section. But we also have a vendor like Tableau with no in-memory database engine rating so highly in the Gartner Magic Quadrant. So why are people choosing products like Tableau over your regular enterprise solutions? So the trends of the last 2 years in particular have seen people choosing new breed applications. And some of the criticisms of the traditional approaches are that they're just too complex and require heavy customization, specialized staffing requirements or rigid delivery models, and perhaps slow pace and certainly expensive. The new applications are basically easy to use and deploy, and so people are adopting these applications for not only data exploration but also using it for the enterprise use. And I guess that crossover poses concerns for how we govern data discovery across the organisation. So here is a typical dual-purpose architecture for how we might go about servicing the needs of data exploration and enterprise KPIs. And to the right, the enterprise BI stack exists. So this is where we report our corporate KPIs and our weekly reports and our monthly reports. And this is how we service requirements that don't change too often. So on the left-hand side of the diagram, we have our data discovery capability. So this is where we give the business access to raw data, and when I say raw data, we still stage the data and we kind of clean it and conform it lightly, but they want access to detailed data. So we want to support the creative process and give the business access that they need to solve problems and identify threats and those sorts of things. So the idea here is that we're giving the access over here, And we're not asking these people here to build detailed requirement specifications. And the thought is there that if we give them access to data, then over a few iterations, they'll come up with an idea of what they want quicker than if we made them sit down and fill out a business requirements document. So what we're going to do now is just go through some of the typical applications that allow us to explore data easily without too many dramas there. So we have Excel Power Query, so for assembling raw data into a usable format. IBM Watson Analytics, so some of the features there for exploration and predictive analytics. Tableau 9 and Microsoft DataZen. Okay, so here we have Excel 2013. As we know, Excel has so many billion users and everyone has it on their desktop. So what we're going to do here is use a product called Power Query to quickly assemble raw data into a format that we can import into some of these predictive analytics products. There's a function here called from file, and basically what we're going to do here is pull out a number of raw files and consolidate them into one big spreadsheet. So each file is sitting in my file system here, and each file is basically a different month for a different state and models energy demand and pricing data for Queensland and New South Wales, which is ironic on the it was not intentional. So what we do here is basically what we're telling this to do is to assemble a long list of files into the one list of data into an Excel spreadsheet. In Power Query, we can do transformations on the fly. So here we might want to chop that character on the far right. So we can use a comma delimited, or if we're actually looking for a number of characters to chop, in this case we want to split by 3 characters. So we just want the New South Wales, we want to get rid of that column. And then we want to rename columns, which we can do quite easily. Here we have our settlement date, which is the date that the demand was recorded and the price that it sold for. So here we might want to extract the time component. So first we can duplicate the column and then click on the duplicate column and change that to a time. And again, we can remove any unnecessary columns and we can rename columns as we see fit. Okay, so once we're happy with all of that, we can actually transform that into one Excel spreadsheet. So close and load, and off it goes, and it manipulates. I think there's 48 files there, and it goes through and rapidly goes through and does what an ETL tool normally does. So once the data is loaded, we can either save the data off to a CSV file and upload to a product like IBM Watson, which I'll show next, or we can actually continue using the data within Excel using Power Query for some pivot analysis, or there's a data mining add-in that you can download for Excel for SQL 2012, which it gives you some advanced predictive analytics capability, clustering, and a lot of other capability. So for a business user, we might want to just make some sense of this data and go into our Power Pivot model. All right, a little bit slow there. There we go. Add the model. So now the data has moved from the Excel spreadsheet into the Power Pivot backend, where it's getting deduplicated and assembled for high performance. What we can do down here is just create a basic measure that we can use in our pivot table, and we're just going to grab the average. And we're going to very quickly create, so we'll rename that to average price. You can very quickly get a sense for whether that calculation is performing badly or very, very well using KPIs. So here we're using an absolute value, and the price roughly fluctuates between 40 and 80 usually. And we can actually change what the red means. So in this case, I want 80 to be very, very bad because I'm buying. So if we just pop into our pivot table there, and we can see our KPI brings back the color, and we can actually get the value as well. So the price actually fluctuates quite randomly, like a rogue wave. Every now and then it goes from a mere $80 to $10,000 in one afternoon. So it's quite an interesting analysis. So we can create very quick analysis and data exploration in Excel. All right, so the next one we'll look at is IBM Watson Analytics. So Watson Analytics is a free tool. You can import a CSV file and analyze data up to 50 columns wide, and I think 100,000 rows or something like that. So you can sign up. So I'll sign in using my free account. So the background with Watson is IBM created an artificial intelligence form that basically defeated a chess player, and then it went on to defeat someone in Jeopardy. And now the same type of, I guess, smarts are sitting behind a cloud-based data exploration and predictive analytics tool. So Cognos is a product under the IBM banner, and so is Watson. So they're trying to look to merge the two products together in the enterprise. So what we can do here is basically once you upload your CSV file, which I've already done previously, you get the option to go and explore a CSV file or actually do some predictive analytics. So we'll do both here. So the same Excel file that I assembled in Power Query, I pulled that into Watson. So here we're just exploring the data and trying to understand what is in that raw Excel file. So Watson has looked at my data file and come up with a model that it thinks it knows what it is, and it's then used, I guess, some predetermined rules to suggest questions about that data. So we can actually type questions, which is quite cool, or we can look through the available questions and maybe pick something that catches our eye. So here we can see what is the relationship between price and demand by month, and that looks quite interesting. So this is 48,000 rows, so it performs pretty well, and you can see along the top there we get some very quick analytics on some of the highs and lows that Watson found in the data set. So $82 was the highest price for the month in January. And down here we have price and demand by month, by settlement date. So we can see the price along the x-axis, and on the y-axis we have the demand. So if we change that to, I have extracted the day from the date, so the day of week, and we just add the item labels on that one. We can see through data exploration that generally the weekdays are certainly higher demand and higher price than the weekends. So very quickly we're getting a sense of what this data is about. So we jump back to our home page and we look at the predictive functionality, and we use the same data set. So I work with a couple of data scientists, and I've showed them this, and they don't like it because they think data science shouldn't be for the masses. It's got to stay within the specialists. So we can select a target, and we're going to select demand, and we can give this prediction a name. So based on no knowledge of the data, we're basically asking Watson to provide some sort of level of prediction using a number of predetermined data mining models, and then give us a chance to actually to look at that and explore a little further. So the more columns wide that you have, obviously, maybe the more work that Watson's going to be doing. In this case, I've fed it, I think it's 5 or 6 columns there, so it's taking 20 to 30 seconds to run all the different mining models over the data.
Peter, while we're waiting for that, does this, if you get a paid full license for this,
Yeah.
you can analyze much more data?
Yeah, that's right. So some of the banks have actually purchased the Watson platform for internal use. But yeah, they got the cloud edition as well. So here we can see what it has come up with. And again, along the top there, we have an analysis of some suggestions there. And the top predictors of demand in this case, firstly, region drives demand. So New South Wales are using more than Queensland. So the predictive strength was 58%. And for the data scientists there, we can actually look at that a little closer, and we can look at the numbers. We can actually look at the details that the statistical model that was used. So we've got linear regression, and we can actually look at the statistical details as part of that model. And likewise, time drives demand. So have a look at that one. So predictive strength of 17%. And the basic idea there is that at about 5 o'clock in the afternoon, we use more electricity and turn on the lights and hit the microwave oven. So you can have some fun with this, and there's a lot of public data that's available that you can upload and just really test out, data science for the masses using the Watson platform. The other tool we've got here is Tableau. So basically, on a similar topic, I've assembled some data for air conditioning cooling hours used by postcode in Australia. So I've pulled that into Tableau, and Tableau is great for not only data exploration but the visualization of that data. So here we have the obviously the darker colours are the larger number of cooling hours used, and in Tableau here it has our intelligent function to actually go and search for specific regions. Okay, so there's the Brisbane River that floods every 30 years. We can pan out, or we can actually just type the continent if we want to scale back. We can use lasso tools to target specific areas, or perhaps look at cyclone impact zones. And from there we can actually create a set and actually do something with that data, or we can actually view the data relevant to those postcodes. And there's a lasso tool, basically more around select shapes. So also in Tableau is
I just
in the
woke
last month.
up. Then I remember I have a meeting. The thing, the seminar.
Can we?
That's okay. I'm using the internet. That's fine.
Okay. So in the analytics pane there, Tableau have tried to actually bring common statistical functions to the desktop.
Last active.
There we go. Brilliant. That's cool. So there's a statistical, for common averages and so forth, which they've put in its own analytics pane. And Tableau have partnered with a product called R. So what you can do here is set a connection to an R-serve connection, and then go and create calculations that go and call out to the R server. So Tableau does support statistical analysis through integration with R. Look at some other cool visualizations. So we've got Fanatics 2014. So the great thing about Tableau is you can be really creative about the visualizations, and at first it sometimes looks like an annual report, but basically what we have here is history of music number ones, and we can see that analysis in the 1950s we had had 36 different artists hit number one in that time, and then we look at the 2000s, we had 319 artists. So, in a very, and we got some context there in some narrative and very easy to bring in pictures. For the Marvel fans, we've got an analysis of Marvel superheroes by the number of comics that they star in. So there's basically like an 80-20 rule there. So here we have top 5 characters making up about 65% of all comics, and further analysis down there showing a 80-20 rule in regards to a series. So the number ones there are obviously Spider-Man, X-Men, Iron Man, and then down the bottom are the nobodies. So yeah, look, very easy to create powerful visualizations in Tableau. So this is a visualization I did in my blog. So I basically analysed the number of new features for each release for reporting services. So back in 2005, Microsoft were introducing all these cool new features, and then SQL 2014 reporting services had one new release, and that was support for Google Chrome browser. So we can see through data visualization the trends of new features being released there. And it is a good product. So finally we have, so one of the cloud-based tools that Microsoft recently acquired, DataZen. So it's more of a cloud dashboarding tool, and we'll pull that up here. So you can download the DataZen publisher off the Windows App Store. And here we can surf through the demo data, or you can create a connection to your own DataZen server on Azure. So we take the corporate scorecard as an example. Just really nice looking dashboards, optimized for different platforms. So we've got Windows desktop, and then there's tablet and mobile, so, and all HTML5. Dynamic filtering, and we can actually go and create our own dashboards fairly easily. And it does support drill through targets to a custom URL. So check that one out. You only need to download it from the Windows App Store. Okay. So now that we've seen what some of the applications can do and how powerful they are on raw data, basically there's a conundrum now for BI vendors to cater for the new breed technology but integrate that into their corporate enterprise platforms. So here are my tips for predicting the next rogue wave. So number one is respect the creative process. And as strange as the business may seem, we need the creative people in our organisation to solve common business problems and to innovate. So these are the people that will basically enhance our business growth and open our customer base and essentially predict the next rogue wave. It's good to give the business enough rope, but don't let them strangle themselves or drown. So this is where the role of data governance comes in, where we start to expose, massive amounts of raw data to people who don't really understand the full impact of the data. So data governance involves creating an information custodian network in the business who are responsible for information domains, and then essentially the person that says no is not the IT person, it's actually the person in the business that's responsible for that data. So the idea is just to help the business be more agile and get on with predicting the next big wave. Tip 3 is basically remember your core business may not be data science, so your core business may be health or energy or coffee. So if you don't know how to do data science, just get the people in for the short couple of weeks, vendors or data scientists, and basically get them into that problem-solving process to help predict the next rogue wave. So that is pretty much it, guys. I have included some references that I came across in my research for tonight's presentation. The pricing demand data is there, the BBC extract, and also some information of Gartner Magic Quadrant and the Tableau samples that I found. So you can go and download those and download a Tableau trial. And finally, we will conclude to see what happened and how scientists came to the solution of predicting how these rogue waves were occurring.
In this world, objects appear and disappear according to one remarkable equation, the Schrödinger equation.
The Schrödinger equation, quantum mechanics. We have TV programs called Quantum Leap and so on and so forth. So we all think we know something about that equation. There's a version, however, modified that describes deep water waves.
Osborne is one of the world's leading wave mathematicians. For 30 years, he's been obsessed with the theoretical waves described by the Schrödinger equation. The equation describes a theoretical water surface where huge waves can suddenly leap up out of nowhere, where for some reason normal waves become unstable and grow huge.
The physics of the nonlinear Schrödinger equation we can see in this simple example. In the beginning, it doesn't seem like there's anything happening, and we could all just give up and go drink a beer if we wanted. On the other hand, we could keep moving forward and maybe something will happen. What we'll see is this central wave here is going to start to grow. It's growing because it's robbing energy from its two nearest neighbors. So here it's starting to come up. You see it's growing, stealing energy from the nearest neighbors, and these waves are starting to drop. See how this is coming down here? Look at that decrease. And Now, in its full glory, it's a very large wave. It has 2 smaller waves on each side and 2 rather deep holes in the sea around the peak.
I think we've got a problem there, but it's pretty much finished. So thank you, everyone. And, you know, I open the floor to some questions about anything we've discussed tonight.
Peter,
Sure.
thank you so much for the information.
Brilliant. Okay. Excellent.
If I were to ask you to look forward a few years,
Yep.
and crystal ball back, where do you think the BI tools would be?
Yeah.
What sort of functionality will they have? How would you
Sure.
analyse that?
I mean, a great example is Cognos and the Cognos developers have been working on Watson, and so you know, essentially, not so much in Watson's instance, but certainly in Tableau, people are going out buying Tableau for the data discovery, and then they're actually using it for the enterprise platform as well. So I think, you know, really the vendors have consolidated a lot. They'll continue to consolidate. I expect some of the major vendors to basically acquire niche data discovery applications. There's lots of them coming out. We can see in the quadrant on the top left-hand corner are the ones likely to be sort of snapped up, the ones ability to execute well but don't understand the full enterprise. Expect big things from Cognos. I'd really love to see Watson incorporated into the enterprise platform. You know, Microsoft are playing a part in the analytics space as well, so they already have cloud analytics in Azure, machine learning. So I guess expect the cloud-based prediction to sort of come back into the enterprise and be a little bit more synonymous with the enterprise tools. Cool. All right, yeah.
So how many tools does a good business user who's not technical have to use to get the information for their management?
Sure. You're talking about power user as a, yeah. So I mean, everyone has Excel, so you got to. That's one. Usually, you have a query tool, so you got a, you know, a SQL Management Studio or an Oracle SQL developer to write queries against, and then you have BI tools. So you know, usually our service provider is responsible for bringing data sources into our common data store and doing ETL. But if you're the one doing the ETL, that'll probably be a 4th tool if you need an ETL tool. And I guess the 5th one is, you know, if we're going to plug into this creative process and be agile, is we need to be agile ourselves, and we need to have a good agile management tool for software development. A product like Jira is really good for, you know, packaging tasks into a 2-week block and doing that delivery to a fixed end date. So you know, 5 tools. There you go.
Can I ask the second question on the end of that?
Yeah.
So as a practitioner, what can we do to help our employers help to get to that state quicker?
Yeah. Look, I think educating on the creative process and actually, you know, respecting that organisations to survive or to sustain margin, they need to be innovative, and part of that innovative process is is the business they need to be supported. So and you know, things change so quickly. So the energy industry, you know, people are using solar panels, and now they're going to be using solar batteries, and that's going to have a massive impact on that price and demand curve that we've been seeing. So yeah.
If you had a monolithic data source that's coming in daily,
Yeah.
which one would you choose?
As in a regular feed, or?
Yeah, just regular. It's coming in all the time, but it's getting bigger and bigger, and you really want to keep as much as you can in the system.
Yep.
Which one would handle it and allow it to grow and still be able to draw out those reports?
Sure. Which tool? Yeah. Look, I mean, any of these BI tools that we've demonstrated tonight are good for light use. So either you've downloaded a text file from your data warehouse, or you've grabbed public data. You know, particularly 32-bit versions of the application struggle. 64-bit desktops probably a minimum. But really, I'd be looking to put that into a database. So I wouldn't suggest you use the tools to build your own data warehouse, but I'd use them to tap into the information that's already in the data warehouse.
Okay, so but I'll give you a scenario then.
Sure.
So you're trying to manage hits from websites and data
Yep.
that sort of stuff. And
Okay.
that's coming far, but you need to respond to it quickly. So you
Yep.
need to see crazy patterns.
Yeah, so you want real time.
You want real time.
Yeah.
Yeah. Which one, if you had to do that job of your project, which one would you choose? As your...
Look, the in-memory databases are very good for that. So SAP HANA is very good for real time because you don't need to wait for data to be transformed and ETL'd into a queue. So yeah, I'd be looking at an in-memory database solution.
Any more questions? Guess everybody wants to see State of Origin, right? I've got one question back to you. Avi, the co-convener, and myself have been asking us what topics you would like to see. If you've got any suggestions, please come and see us afterwards. We're happy to take them on to have talks like today's who are relevant to everyone. And I think we can say for sure that this was very relevant and very well presented. Thank you, Peter.
Very good.
And please stay around for the networking. And other than that, thank you very much for coming.